This video is just a brief introduction and a little bit of a discussion about air conditioning vacuum pumps, okay, or refrigeration vacuum pumps because they're used on both air conditioning and refrigeration systems. So a vacuum pump is a vapor pump, not a liquid pump, and it's used to create a vacuum for evacuating a refrigeration system of moisture and other contaminants before refrigerant is recharged into the system. So this is a typical vacuum pump, might or might not have an oil or a vacuum gauge, always has an oil drain plug, always has an oil level sight glass, has isolation valves, has intake port, and a carrying handle. Be careful because the carrying handle a lot of times is also the vacuum pump exhaust. So you might not have the separate exhaust. It might be through a hollow handle. A high vacuum pump will produce a vacuum higher than 28.92 inches of mercury vacuum. Most manufacturers are now recommending a vacuum of 500 microns prior to charging a system. The lower the micron count, the greater the vacuum. This can take several hours depending on system size. Creating such a low pressure condition is necessary to completely dehydrate the system. Do not rush vacuums, okay? Again, the lower the vacuum number in microns, the better off your vacuum is going to be. It is necessary to remove all substances from the system because any foreign material can cause higher pressures than usual and possibly damage the system. HVAC technicians need to be very familiar with the vacuum pump specifications in order to choose the proper vacuum pump for a given job. Ultimate vacuum is a rating of the highest vacuum that a vacuum pump can pull. It is the most important specification of a vacuum pump and is usually measured in microns. The lower the number of microns, the higher the vacuum a vacuum pump can pull. Ultimate vacuum may also be called blank off pressure. Free air displacement is at the speed at which gas can be pumped through a vacuum pump. It is measured in cubic feet per minute. The higher a vacuum pump pumps free air displacement number, the more gas is moved per minute. Free air displacement may also be referred to as volume capacity. Okay, so when we're talking about the free air displacement, it's in cubic feet per minute. A 1.5 CFM vacuum pump can handle a 3 to 5 ton residential system. 3 to 5 CFMs can handle 5 to 100 ton medium systems, and 10 to 15 CFM can handle larger system over 100 tons. Now here's the key. The more CFMs, the more you're going to pay for the vacuum pump. Okay? It does not hurt to use a 3 to 5 CFM on a 3 to 5 ton residential system. Okay, you're going to pull a nice vacuum on it and you're not going to be there forever. There are two main types of vacuum pumps available. You have a single stage and a tube stage. Single stage vacuum pumps use a single pump mechanism to draw a vacuum. They cannot be used to draw the deep vacuums required of the 500 microns. They can only be used for like the triple evacuation method when you're only drawing 1500 microns. So again, single stage vacuum pumps, stay away from them. Two stage vacuum pumps consist of two pump mechanisms working in series. Two pump mechanisms working together are able to draw a vacuum more efficiently than a single pump mechanism working alone. These are used when deep vacuum methods are used. Two-stage vacuum pumps is what you're going to find on most service trucks and in most supply houses now. This is a two-stage vacuum pump. We have a first stage that gets the first inlet from the system, that's the blue, and then we have a second stage that's in red, takes the output of the first stage and further draws a vacuum. The purpose of oil in the vacuum pump is to act as a lubricant for the pump and as a fluid seal between the air, gas, and contaminants entering the pump from the refrigeration systems. During evacuations, gases and water vapor pulled from the refrigeration system often become trapped in the oil, which raises the oil level of the pump. Most vacuum pumps have a sight glass that allows the technician to check the oil level and oil color. Vacuum pump oil should be replaced frequently since oil rapidly becomes dirty when water and solvent vapors are drawn and dissolved into it. Water will also turn the oil white and foamy. Don't use a vacuum pump for a year without replacing the oil. Change that oil frequently. Sometimes if you've done a large job, change it after each job. Vacuum pump oil is not that expensive, and the savings you will get of time and effort for changing the oil is great. If dirty oil is left in the pump, sludge will form and the pump life will be reduced. Then when vacuum pump oil is clear, it means it's clean. For good evacuation results, change the vacuum pump oil before each system evacuation or test the vacuum pump. The quickest way to test a vacuum pump is to isolate the pump from the system and pull a vacuum on the vacuum hose only. Use a T-fitting and connect an electronic vacuum gauge between the vacuum pump and the center port of the gauge manifold. Close the low and high side gauge manifold valves. Start the vacuum pump. Allow the vacuum pump to run long enough to pull a vacuum of about 500 microns. Turn off the vacuum pump and wait 2 or 3 minutes, allowing the vacuum pressure to rise as moisture boils off inside the hose. Pull another vacuum down to 500 microns. Watch the vacuum gauge reading. If it rises, check for leaks at the hose fittings. If the pump will not pull down to a high vacuum, change the oil. Always follow the manufacturer's recommendation. Key thing, if you have a system that is leak-free, if you have gauges that are leak-free, if you cannot pull a 500 micron vacuum with a vacuum pump, change the oil. If changing the oil doesn't work, recheck everything for leaks. But if you cannot pull a 500 microns just on your gauges, you have a bad vacuum pump.